Hi, I'm Colin Walls, and I'm here once again to talk about embedded software. Today, I'm going to discuss a subject which traditionally was not considered to be a software issue at all, and that's power consumption. Historically, power consumption was purely a hardware topic. You wire the thing up in the right way, it consumes the minimum amount of power, was the general philosophy. However, in recent years, it's gradually been realised that software can have a significant influence upon the power consumption of an embedded device. First off, you can get a real-time operating system with built-in power management. That's an option provided by many companies, including Mentor Graphics, and that's a subject perhaps for a talk on another day. But there is a more fundamental level that we can look at power consumption, and that is the operating system itself. Some operating systems cause your application to consume more power than others. Now, how can that be? It's actually very simple. If the operating system is very large, it will use more memory. Memory uses power. If the operating system is relatively inefficient, it will execute more code to get a particular job done. More code execution means more power consumed. So if the operating system is efficient and consumes the minimum amount of power, then the job will be done. Now, a colleague of mine did some research into this. He figured he needed to measure this rather than just intuitively guess that's what would happen. So what he did is he wrote some code which would decode an MP3 file containing a sound, which is a 71 decibel, 220 hertz sine wave. Very simple sound. So he expected the code to just execute smoothly. He then implemented the code twice on the same hardware, but once using the Nucleus real-time operating system from Mentor Graphics, and the second time he did it was using Linux. Bearing in mind Linux is not a real-time operating system, but it's very popular. He then ran the code and measured the power over a period of time. The results he got were very interesting. We can see on the plot here, horizontally is time and vertically is power consumption. The magenta coloured stripe along the bottom is the consumption by Nucleus. It varied over time, it went up and down very, very rapidly, but as you can see, over a fairly minimal band, and it's fairly low in the level of power consumption that it's using. The dark blue plot is what Linux consumed. As you can see, it's about 25% more power than Nucleus, doing the same job on the same hardware, 25% more power. Well, that's kind of interesting, and that is more or less what my colleague expected and wasn't surprised. However, what he was surprised by were some odd peculiarities in the plot, particularly this great big spike here where there's an extra 20% of power being used. What's that being used for? We have no idea. It is Linux doing its own thing, Linux doing something that it felt was necessary at that time. Remember, Linux is not a real-time operating system, so being predictable is not a requirement. Real-time means predictable. So not only is it inefficient, but we've illustrated in power consumption terms the difference between a real-time operating system and a non-real-time operating system. I hope that's an interesting topic and something we'll investigate again one day when we look at power management in real-time operating systems. But for the moment, that's all, and I'll look forward to speaking to you again soon. Bye for now.